So in the last section we talked about the Earth was getting warmer, and in this part we're going to talk about why it's getting warmer. And the major reason is rising concentration of what we call greenhouse gases. Green is nice. Okay. And this is one of the major greenhouse gases is carbon dioxide. The other is methane. But this is a measurement of just CO2. It was done in Hawaii. And you can see that the level of CO2 measured in parts per million varies seasonally, but that we have a steady uptick from 2016 to today. I actually pulled this off the NOAA website, so it goes right to April 2021. This is a little longer time frame. They've been taking measurements at this station in Hawaii for a long time, and it looks like they started around 1960, and you can see there's a steady uptick of CO2 in our atmosphere. Now we can go back and look at even longer timelines. This is data that is taken from ice cores. So an ice core is a cylinder of ice drilled out of an ice sheet or glacier. Crucially, the ice encloses small bubbles of air that contain a sample of the atmosphere at that time. And it's possible to measure directly past concentrations of gases in the atmosphere, including carbon dioxide and methane. So that's how these were done, and these are thousands of years before today. 0 is 1950. And if we go back 100 years, 200 years, 300 years, and so forth. And what we see is that the level of CO2 does vary. It has gone as low as 180 and as high in the past as about 300. But today it's substantially above 300. Today it's in this range, a little above 400. So how has this happened? Why do we have more CO2 in our atmosphere? Well, what we find is that CO2 is removed from the atmosphere by photosynthesis. So here's photosynthesis, and remember our equation. We take CO2 and sunlight, and we're able to make hydrocarbons, and we make oxygen. And CO2 is also removed by going into the ocean. More about that later. CO2 is released by cellular respiration. And you'll recall that from your when we talked about cellular respiration, that in cellular respiration we take our hydrocarbon plus oxygen and we make carbon dioxide and a little bit of energy. CO2 is, these two are basically balanced. Photosynthesis and cellular respiration are pretty much in sync with each other. What's not in sync is the combustion of fossil fuels, because this also releases CO2. Fossil fuels are coal and gas and oil, and they have hydrocarbons that were put down or stored many, many years ago in ancient times. And then we release them by burning all at once. We're releasing a lot of CO2 into the atmosphere. Now, more CO2 is absorbed by the ocean than is released, but we have a problem with that because CO2 plus water will make carbonic acid. And carbonic acid, as the name implies, is acid, and it will lower the pH of the oceans and make it uninhabitable for a lot of creatures. Climate change. Okay, so CO2 is removed from the atmosphere by photosynthesis. CO2 is released by cellular respiration and by burning fossil fuels and organic material. More CO2 is absorbed by the ocean than is released, and it makes carbonic acid in the ocean, lowering the pH. So climate change can affect biomes, ecosystems, communities, and populations. So a biome is a large naturally occurring community of flora and fauna that occupies a major habitat, either the forest or the tundra. And what we find is that these biomes are shifting. We're beginning to find shrubs and conifers, that's pine trees, in the tundra where normally they wouldn't survive. Deserts are being enlarged, and rainforests will turn into savanna. We're finding that the fire seasons are longer and start earlier. This is a picture of San Francisco, and we don't have a date on this. This was last year. My children lived in California. They were with me during this period, but they were they were working with their colleagues in California, and they were looking out the window and they were seeing this orange sky due to all the fires in California last year. What we're finding with climate change is that spring greening and flowers are occurring earlier, but since some species use day length and not temperature, they find themselves out of sync. This is a timing mismatch. Many animals are shifting toward the poles to get cooler or to higher elevations to get cooler. More than 24 species of butterfly have moved north by as much as 150 miles, and robins are now seen north of the Arctic Circle. In addition, mosquitoes are appearing at higher elevations and they're more able to spread diseases.